Oh, hey, I didn't see you there. I'm Brian Falvey.
And I'm Zack West.
And this is our Sumo Bot, BONECRUSHER. Alright, so this is what our robot does. In the front of the robot, there is an IR sensor. The IR sensor is hooked up through the robot to the chip kit, which is hooked up to two H bridges, which is hooked up to two 12-volt motors. What it does is when there is no object or obstacle that the IR sensor senses, the motors spin opposite, or the wheels spin opposite directions, turning the robot. When it finally does see an object, both motors are programmed to move forward, thus hitting the object and knocking it out of the ring. So here's an example of what our robot does when it does not sense something. And here's what happened when it does.
So now that you've seen what it does, it's time to explain how it does it. So basically you have a box-like structure here in the back that contains all the interiors, such as the PMOD shield chip kit, which are connected to the two H bridges, which then power the two motors that are inside here by two 9-volt batteries. So all of our programming was done on an MP IDE program on our laptops. In the header statement, I declared all the variables, such as the direction in the first motor and the second direction in the second motor, to their correct pins. So as you can see, the first direction is to pin 26, the first motor is connected to pin 27. I declared the analog in pin to the pin A0. The direction 2 is to pin 30, the second motor is to pin 31, and these integers of sensor value and output value, are set to 0 because those are according to the IR sensor, and the hardware obviously isn't seeing anything in the very beginning. So there are two separate void loops in the program, and the first one is the void setup. So in the void setup, you can see that we have the variables again here, the direction, the first motor, second direction, and the second motor. And we declare their pin modes as all outputs. The last part is the serial begin, which is according to the IR sensor, and that's the void setup. So the last part of the program is the void loop. So as you can see here, there's two initial values that need to be set for the IR sensor. The sensor value is going to read it, and the output value is what's important to the program, because as you can see, it's put to the if statement, if else statement, as an inequality if it's less than 70, which is actually a certain distance, but just put into a numerical value. If it is, if this statement is true in the if statement, then the digital writes basically tell the motor to switch directions and go opposite directions, so the robot is spinning, as you saw earlier in the presentation. If it's outside this inequality, it probably means that it's closer. It tells the digital writes, tells the motors to both spin forward. That's the program.
Alright, so for the design of our robot, we made it out of all metal. We spray painted some teeth and eyes on it, give it a intimidating sort of look. Basically, we have obviously the chip kit and the 12-volt motors, along with two wheels. We have two switches. This one is for the 9-volt batteries that power the motors, and then this one is for a 9-volt battery that powers the chip kit. And that's the basic design. So now that you've seen our robot, it's time to actually see it in action.
Fight.